Graph encoder decoder. Description. A graph encoder decoder JADE model is used for tasks involving graph structured data, where the model both encodes an input graph into a latent representation and decodes this representation to predict or generate output graphs. Key components. Graph encoder. Description. Converts input graph structure into a latent feature representation. Graph decoder. Description. Generates or predicts output graph structures from the latent representation. Attention mechanisms. Description. Optionally integrates attention mechanisms to focus on relevant parts of the input or output graphs during encoding or decoding. Mechanism. Graph representation. Description. Represent nodes and edges of input graphs using node embeddings and adjacency matrices or other graph representations. Encoder. Description. Utilize graph neural networks GNNs or other graph embedding techniques to encode graph structure into a fixed dimensional latent space. Decoder. Description. Employ generative models or graph generation algorithms to decode latent representations into output graph structures. Working. Encoding. Description. Process input graph nodes and edges through multiple layers to capture hierarchical features and dependencies. Latent space. Description. Represent input graph information in a continuous latent space suitable for downstream tasks. Decoding. Description. Reconstruct or generate output graphs from the learned latent representations, preserving structural and relational properties. Applications. Molecule generation. Description. Generate new chemical compounds based on learned patterns from existing molecular graphs. Graph translation. Description. Convert graphs between different domains such as social networks to knowledge graphs. Graph editing. Description. Modify existing graphs by adding, removing, or modifying nodes and edges while maintaining graph integrity. Advantages. Structural preservation. Description. Preserve inherent structural properties of input and output graphs during encoding and decoding. Scalability. Description. Scale to large graph datasets and complex tasks using parallel processing and efficient graph algorithms. Challenges. Representation learning. Description. Learn effective representations of graph structures that capture both local and global dependencies. Evaluation metrics. Description. Define appropriate metrics for evaluating the fidelity and quality of generated or predicted graph structures. Recent advances. Hierarchical encoding. Description. Introduce hierarchical graph encoders that capture multi-scale features of graph structures. Attention mechanisms. Description. Enhance model performance by integrating attention mechanisms tailored for graph structured data.